Hello and welcome to another Learning with Greg video on programming, and in today's video we are talking all about custom blocks inside of MIT Scratch. So if you've ever done any coding inside of MIT Scratch and you've wondered, hey, what is this option for creating custom blocks that I have? Or maybe you have some programming experience and inside of Scratch you've wondered, hey, how do I create functions inside of Scratch? Then this is the video for you, because the custom block is the Scratch equivalent of creating a function. And if you're a programmer, you know functions are one of the fundamentals of programming. They can help you save tons of time and just be way more efficient with your programming. So if you want to learn all about custom blocks inside of MIT Scratch and see just how easy they are to use, then stick around. Welcome back. In this lesson we are talking about custom blocks inside of Scratch, and we are talking about the dry principle, which is sort of one of the fundamental principles you're going to find in coding. And dry in this case stands for don't repeat yourself. And the whole idea as you progress as a coder is just to be as efficient as possible. So you don't want to use 100 lines of code when 10 lines of code will do. You don't want to repeat the same lines of code over and over again if you can somehow come up with a way to call those lines of code and sort of work in a smarter fashion. So that's where custom blocks are going to come in. And custom blocks are basically synonymous with, in other programming language, you can hear them called functions. Sometimes you might hear them called procedures. If you get into object-oriented programming, you may hear of methods. All these things are basically the same idea. And basically it is you can encapsulate several lines of code and call those lines of code only when you need them. Okay, and you can even pass in parameters of variables. They're going to work within those lines of custom code. So custom block is just going to be a set of instructions that we can call. Now, this is going to be best shown with an example, and then you'll really start to see why this is such an important coding principle, why it can make your code easier to read, more efficient, and why it can just save you tons and tons of time. Okay, let's work through a couple examples, because examples are really going to show us how these custom blocks work, how you set them up, and also really drive home this dry principle, the idea of writing dry code where we don't unnecessarily repeat ourselves. You always hear if you repeat something, once in a code, that's fine, but if you find yourself repeating it a second time, then really it's time to think about using a function, a custom block in this case. And so let's get into this. Okay, for this example, I'm actually going to load an extension here just so we can sort of work with this extension on screen. So what I'm going to do is just come under here, under my coding menu. You'll see this plus in the bottom left. So I'm going to click that and I'm going to bring in this pen tool, and it's basically just a tool that lets us draw on screen. So I'm going to click that. It loads it right in here, and what it does is it gives us another option down here in our coding menu, this pen option, and now we have these additional blocks within our menu here under this pen menu. So what I'll do first is I'll just come back, and we have this sprite here, sprite 1, Scratch Cat. He's fine. We'll keep him in this project. And I'm just going to come back to motion here. And actually, let me go under events, and I'm just going to set up some initial conditions here. So I'm going to make Scratch Cat a little smaller. We'll start with him in the center of the screen. So for motion, we're just going to make sure when the green flag's clicked, he's at 0, 0. And let's check, and let's change his size. So we'll come under looks here. And let's see, set size is going to be under here. So here, set size to, let's just make them 25%. Let's make them somewhat smaller. So just something like that, just to have a sort of a starting thing there. That's fine. Okay, now we're going to use that pen extension that we just installed to draw on screen. So let me show you how that works. I'm going to come under my pen block here. And you'll see you have a bunch of different options here. The erase all option is just going to erase anything on screen. So that's not a bad initial condition to set, just to make sure anytime we click that green flag, we're going to start with a clear screen. And then as you move around on screen with Scratch Cat, if you have your pen down, he's going to draw on screen. If you lift your pen, then he's not going to draw anything. So let's start with the pen down. And then we're going to change the pen color, which you can set to whatever. I'm going to set it to black since that's going to be easy to see. And then just to test that he does draw on screen, we'll just start with an easy motion block. So let's come in here and let's find our move block in here. Where are you, move block? Why can I never see you? Move block. Right here, right at the top. I couldn't find it, it's right at the top. So there we go, move. And let's set that to 100. So 100. And then if I just go full screen and we run this, we see, yes, when I hit the green flag, he moves 100 steps. And because we put the pen down first, he is leaving a little line on screen. Now, imagine that instead of drawing a single line, we wanted him to actually draw a square. So what would we have to do to make that happen? Well, he would have to draw the first line, and then he would have to turn 90 degrees clockwise to be able to be ready for the next line. So essentially, he would go 100 steps, he would turn right 90 degrees, and then essentially we would repeat that step 4 times because he'd repeat that for each side. So if I come back here after my code, back into my code, we're going to have him move 100 steps, and then we'll have him make that turn, which is going to be a 90-degree turn. So 90 degrees. And then essentially we're going to duplicate that 4 times, right? Duplicate, duplicate, duplicate. Now he would complete the square even without this final step here, but that final step is going to ensure that he ends up, again, pointing back the direction he started. So if we wanted to at the very beginning of all of this, we could make sure that at the very start when the green flag is clicked, let me just take all of this and let's make sure when it first starts he is pointing towards 90 degrees, which is the right side of the screen. And if you click on that, it'll give you a visual representation there. And then we're going to make sure we erase and set all of that. So let's just do that to start with here. And I'm just going to disconnect my blocks for a second, and then I'll bring them back up here. But so now if I do this and we go full screen, we can see that when I click this, yes, he does actually draw a complete square and he ends up back where he started. Now that's great. However, if we go back and we look at our code, imagine we wanted to draw lots of squares on screen. If we had to drag out all of these blocks each time, it's not actually the most efficient way to write this code. Because we're repeating this 4 times. So first of all, we could take all of this and we could just make use of a repeat block. So if I come under control and we grab one of these repeat loops and we want to repeat this 4 times. So right now we have 1, 2, 3, 4, 5, 6, 7, 8 steps, right? Because we're doing move and turn, and then we're repeating that 4 times. So if I just got rid of all of this, now suddenly from using 8 blocks, we're just going to use this one repeat block and these 2 blocks. So we've gone from 8 blocks to 3 blocks, and this should work exactly the same way. So again, let me just disconnect it for a second just so we can clear the screen. We'll put that back on, and we'll come here and we'll test this again. And I'll hit play, and we see it works exactly the same way. So we have the exact same result, only this time we're doing it with these 3 blocks instead of with these 8 blocks. So we've made our code more efficient. But let's imagine we wanted to go from making this 1 square to making lots and lots of squares on screen. Are we going to have to use this repeat 4 every time? Well, that would be more efficient than using these 8 blocks each time. However, we can do even better if we turn this into a custom block. And essentially what this custom block is going to do is going to create a square, because we want this to create a square. So what I'm going to do is I'm going to come under My Blocks, this My Blocks tab. This is where you're going to create all your custom blocks. And again, a custom blocks is basically a set of coding blocks, a set of instructions that you can call whenever you want. So I'm going to click on My Blocks, and I'm going to click on this Make a Block. And you can give it a block name. We're going to call this Draw Square. Okay? Draw Square. And we're now going to be able to attach blocks to this. But the one thing I'll say is that you can come in here and you can add an input parameter. So we can pass something into this. For example, maybe we want to pass it, what size we want the square to be. Maybe we want it to be the color that we want the square to be. We'll come back to it in a minute. But for now, we're not going to add any inputs because you don't have to add an input. For now, we're just going to click this draw square. We're going to call it draw square, and we're going to go ahead and click OK. And then here we go. So now when you do that, suddenly you'll see that you have a new block over here, and then you'll have this block over here, sort of this capstone block. I call it a capstone block. Basically, this is one of these blocks where you can attach stuff to it below. So under this define draw square, this is where we're going to put the blocks that are going to run anytime we then add this draw square to our code. So what we want to do is we want to put this repeat 4, and we want to put that right here, but also maybe under here, maybe this is where we put the pen down, and maybe this is where we set the color. So I'm going to put the pen down, set the pen color. That way I'm making sure every time that we call this block, we're definitely going to be drawing something. We're going to be drawing something in this black color ink, and we're going to repeat 4 times this square. Okay? And then we're going to take all this and we're going to instead, so now if I click the green flag, it should clear everything, right? Because we're erasing everything on screen. But now if instead of all of the blocks we used before, now we just have one block, this draw square block. And just to see that this works, I'm going to come back here, I'm going to hit play, and the exact same result. So you're starting to see how by creating custom blocks like this, you're just coming up with a more efficient way to sort of organize your code, because if I back out now anytime I want to draw a square, I just draw a square. That this block is very intuitive in terms of I've named it in such a way that we know what that's going to do. And if I ever want to see what blocks instructions that's calling, well, I just have to find this part of my code here. This is where I'm actually defining what this block does. In other languages where you're actually writing the code in sort of a word processor, it's going to be the same sort of thing where you define a function, you define a procedure, and you give it a set of instructions, and then in another part of code, you're going to call that function, call that procedure. In this case, calling this custom block. What custom block are we calling? We're calling draw square, and here is where it's defined. Okay, so these are custom blocks. Now we're going to continue forward with this example in the next lesson. But this is just an intro to get you excited about how this potentially could save you a lot of time and be a more efficient way of writing code. Well, it certainly is going to be when you start to write more complex code, and we'll take a look at that and see how we take this even farther in the next lesson. Okay, in the last lesson we started talking about custom blocks. We talked about how they are important so that we can write even more efficient code. And now in this example here, we were trying to draw a square on screen with our pen extension. And we saw that we started with these blocks here, and then we were able to make that more efficient by moving to a repeat loop where we repeated 4 times and repeated these steps. So we went from 8 blocks to 3 coding blocks. But then we saw how we could encapsulate all of this into a custom block. So now anytime we want to draw this square on screen, all we need is this one block. So in essence, we're avoiding repeating ourselves. We're making our code cleaner. We're making it so we can more efficiently now build going forward because we just have the one block. Okay, so let's take this even farther. We drew this square on screen, and that's pretty cool. But what if we wanted to draw something even more complex? Maybe we want to take this square shape and repeat it, make something that's more a little bit like a flower pattern. So imagine this. What if under draw square here, once we complete the square, we just have him rotate some number of degrees. And so I'm also thinking about the fact that I know that to rotate fully around in a circle, that's 360 degrees, right? So I'm going to keep that in mind when I build this out here. I'm basically going to do a repeat loop. I'm going to repeat it 10 times. And what we're going to do is we're going to draw a square at the start of the loop, and then at the end of the loop, we're going to come under motion and we're going to turn. Now, if I'm doing this 10 times to complete that 360 degrees, I know I have to turn 36 degrees each time. So again, I'll just hit this to just clear. I have nothing attached anymore, so let me just clear the screen. Now let's bring this repeat 10 times, and we'll go into full screen mode, and let's check out what happens now when I hit this. So now he's drawing square after square. He's turning, so he's drawing a square, he's turning 36 degrees, he's drawing another square, and he repeats that all the way around. So now we have this cool flower pattern, and we've done this by just utilizing our custom block within a loop. Well, imagine that this new pattern is something that we like, and we might want to draw that again, okay? So we could bring up these blocks every time, and every time do a repeat block. But again, if we found ourselves doing this multiple times in our code, again, it might make sense to create a custom block so that we can make our code more efficient, easier to use, don't repeat ourselves. All these things are things you want to try to do. So again, we could create another custom block. So make a new block, and we'll call this one draw. I'm just going to call this a flower pattern, since that's sort of what we've created on screen, draw flower pattern. And we'll go ahead, and again, I'm not going to add input yet. We'll get to that in a minute. And we'll go ahead and click OK. And so now under draw flower pattern, what do I want to do? Well, I want to just repeat 10 times, and I want to have this draw square block. So this is good to note here that you can call a custom block within another custom block. When you write functions in coding, you can do the same sort of thing where you can call one function within another function. So what essentially we're doing is we're making use of this draw square set of instructions within this new set of instructions that we're defining. And so again, now when you create a block, you have a block you can draw out on screen. So now if I replace all of this, let me just, again, clear the screen. If I replace all of this with this draw flower pattern, then again, I could play that and make it draw on screen. If I wanted to see that, yes, it's working, I could do something like, I could do a control loop now, and I could do something like repeat 36 times. So let's repeat this 36 times. And each time I go 36 times, I want to draw the flower pattern, and then I want it to rotate at the very end of it 10 degrees. So if I do something like this here, then suddenly, let me just do that to clear the screen. I'll put this block here, and then we'll come out here, and we'll go ahead and click this on screen, and we'll watch it go, and it's going to keep going, and basically it's drawing that star pattern, then it's doing it again, so we're getting this more and more intricate pattern on screen, and so that really is pretty cool. Now I'm going to stop this for a second, and you can see it's taking a while here to go through the steps, and I'll talk about that in a second too. But let me just stop this for a second and step out of here and come out of here. And so, look, this is repeating 36 times, and every time it does that, it's calling this draw flower pattern, and within this draw flower pattern, we have this repeat 10 loop, and then within each loop, we know it's drawing a square, and within each square, we know it's doing these steps. So, wow. Think about this. If we, instead of making use of these control loops, these repeat loops, instead of making use of custom blocks, if we had tried to draw all this by just using blocks of code without using some of these structures that we have, we'd have hundreds of blocks of code on screen. And now those 100 blocks of code have been shrunk down to this small little loop here. So again, and we could take all of this, if we like this shape here, and we could put it in another custom block. So again, just think of the way, if you have patterns or things you want to repeat building blocks that build up to something bigger, and then maybe you like that. So think about storing things in functions and custom blocks that you can recall just to avoid repeating yourself, to give yourselves the ability to code in a smarter way, in a more efficient way. Okay, so let's back up for a second. We've done all this. We've seen this is really cool, but I talked before about how you can actually pass parameters into the code that you write. So let's drag all of this out of here for a second. Let me just go back to my blocks. Let's just do this simple draw square. So if I go back to this, now we're drawing a square on screen. Okay? But let me come in here and we can right click on a custom block that we've already created and we can edit that. So I can come back in here and now I can edit this. Well, imagine that we don't always want our square to be 100 pixels for each side. Maybe we want the length to change. So I could add an input. I'm going to call this number of text, but I'm going to call it length just so I know what I'm passing in. And I'm going to go ahead and click OK. So now draw square, and here is my thing, define draw square length. But so now this length is a variable I can pull down and use somewhere in here. So instead of move 100 steps, I can have it move length steps. So now I'm going to pass in the length that I want the sides of my square to be, and then it's going to make use of that as it's running this block. So you notice now that my draw square block requires this input. So if I hit play now, see nothing happens because it doesn't actually have the input it needs. But if I go ahead and I put in here, and I put in 25, and then I draw this again, you can see it's created a small square on screen. Well, maybe we want it to be like it was before, or even bigger, 125, and now, boom, draws at 125. So now we've given it a parameter that we can pass in. So now this is even better because now not only do we have a set of instructions we can call, but we can make that do certain things. We've given it some flexibility. We've built into it the ability to have this variability within it because we're passing in this length variable. So hopefully you're starting to see the ability to use custom blocks, the ability to use functions and procedures in other programming languages. It really, really is a valuable tool in your arsenal. Okay, we're going to stop this lesson here, but we're going to have one more lesson on custom blocks where we look at a few more options you have and a few more things you may want to consider. Okay, in the prior lessons we've been talking about custom blocks. We've seen how useful they are, how they can help you repeat code and code more efficiently, and we've also seen how you can pass a parameter into your custom blocks. Now we're going to go even farther because you can actually pass more than one parameter into a custom block, and there are a few other things to consider, so let's take a look now. So I'm just going to right click on this define draw square custom block that we have, and I'll go ahead and choose edit. Okay, so if you want to add multiple parameters, you can do that. You just have to add multiple inputs here. So I have a number text input here for length. I'm just going to add one more, and this one I'm going to call pen size. Maybe we wanted to pass in the pen size. So I'll go ahead and click OK. Now when I do now we see we have these two variables here, and we have these two inputs over here on screen. So maybe I'm going to pass in a pen size of something like 5. Of course, then to use that over here, I have to make sure I drag and make use of this variable that's being passed in somewhere down here in the coding blocks below. So I'll grab this set pen size, we'll put it right up here, and we're going to drag down this. And so now we should be passing in a pen size of 5 and setting that here before we actually make the movement and draw the square. So I've hit play to test this. Yes, this works. So now we're not passing in not only the length of the size, but we're passing in the also the pen size. So length of a side 50, pen size, let's make that even bigger. We see that yes, I can now pass in both of these, and both of these are being used by this custom block or this function here. So that is really cool. Now something to consider here is on my define block here, the actual custom block itself where we set up the instructions for that block, I can see because of the descriptive names I gave this that this is drawing a square and I'm passing in length and pen size. I've given it those names. However, over here on the actual block itself where it's being used in my code, I just have these empty inputs when I first start out. So you can imagine a situation where you start to have a lot of code here, and maybe you're not always going to see this define block, and maybe you want to make this more user-friendly. You could do that by adding in labels. So let me show you how you would do that. You come over here, and you right-click again and have edit. Now what it does do is it doesn't give you a way to drag and drop and reorder things up here. So if you have any of them highlighted or selected, you'll have this trash can icon. So I'm just going to throw out the pen size for a second, and after the length here, I'm going to add a label. And I'll just call that with the same name, length. So now I'm calling that length. And then I'm going to re-add that input for pen size. And then I'm also going to give that a label, and I'll just label it what I called it, pen size. And so now if I click OK, now we'll see that now on the block itself, it says draw square, that's what it's doing. But I can see that I'm passing in the length. So we'll pass in 100, we're passing in pen size, so I'll pass in 2. So this is just a way, if you know maybe your code's going to get a little complicated, you want to have a reminder to yourself or to another user of what these inputs actually are, you can add labels like this. The block itself is still going to work in the same way. You can still make all these adjustments, but now you can see what you're passing in. So that can be helpful. Let's just go see what else we have for options here under this define block. So I'm going to come back in under edit. So we've talked about number inputs or text inputs you can pass in. We've seen you can pass in a label. What about this option here, a Boolean? Well, a Boolean variable is just something that's going to resolve to true or false. So you can test within your function a condition, and you can see whether that condition is true or false. Now, to see how this might be used, it's probably best to do an example. So let's add an input, and let's call this one check, or let's call this side length check, something like this, something that's going to make sense. Side length check, and again, you could add a label. I'm not going to add a label in this case. I'm just going to go ahead and add that. But we can see based on the different hexagon shape here, it's looking for a different input because it's looking for some condition that we're going to be testing to see if it's true or false. So, for example, let's just make this really simple. You could be testing any condition. I said side length. But we could also just very easily come over to our operators here, and just for very simple purposes, let's just go here and let's put 50 equals 50. So that is definitely going to be true, right? So 50 equals 50. So now if I come down into my actual thing in itself, we'll see I'm passing in this 50 equals 50, and then I can access that condition check up here. So if I went down into my control blocks here, and I did this if then else, and so what I'm going to have is, I'm going to drag this down, and in the pen color, I'm going to make a variable that has subject to change based on that condition. So if I drag this side length check down, it's basically saying if 50 equals 50. So if that resolves to true, 50 equals 50, then it's going to set the pen color to black. However, if not, I'll duplicate that block and we'll set the pen color to something else. Let's set it to like a red. So if 50 equals 50, it should be a black square that's drawn on screen here. Otherwise, it should be red. And of course, I'm going to bring this back up so we're actually drawing something. And so boom, I run that check. Everything's the same. But the test that this is actually working in doing this check, let's set it to 21. Well, 21 obviously isn't equal 50. So when it does is 21 equal 50, we should expect it to bump down here and to go to red. So let's just see, does that work? Yes. So you can add in Boolean checks like this, just more conditional logic, so you actually can pass a condition in to check within your function, so then you can have your function maybe do something if this condition is true, maybe not do something if it's not true. So it's just another way to make even more use of functions or custom blocks like this. You can add in these condition checks. Now I called this side length check, so for example, we're passing in this length here, right? So I could do something like this. Let's just do another variable actually within my code here. I'm going to call this for this sprite, and I'm going to call it side length, something like that. And we'll go ahead and click OK. And now when the green flag is clicked, let's set that side length. And let's set it to, for example, let's start by setting it to 50. Okay. And so instead of using this 21 here, let's actually use that side length variable, side length 50. Okay, so now it's actually checking right here. It's taking this side length, is it equal to 50? And we'll run the same check in here, if side length is equals 50. Well, now we have 50 and 50, so 50 equals 50. So we'd expect this to be black again, because now we're making use of this variable. And side length check, we're checking that. Yes, so if it's 50, we're getting this black square. However, if we change the size to anything else, so let's just go to 50, run it again, now we're getting red. Okay, so you can pass in a variable like this. Okay, so that covers most of the options here with these custom blocks, but let's just work through one more example, because it's important that we understand just exactly what's happening here as we pass a variable into this custom block. Okay, so I'm going to edit this because for this example, we're not going to use this Boolean anymore. So let's just get rid of that Boolean. We'll click OK, and then we'll come down here in our code, and let's just set the pen color back to black, and we'll just put the repeat up there, and we'll get rid of this if then else check, and we don't need this anymore, so we'll drag that out, just cleaning things up a little bit. Okay, so the way it happens now is we still have this side length variable which we're setting, and we're passing in the side length here, which actually I want it here, not for pen size. So we're passing in the side length, and we're passing in a pen size. Now we're passing in the side length we're passing in the side length with this side length variable. Now, as we get in here, then we're coming down and we're grabbing this length here, and we're using this length. This is kind of important because as soon as you pass a variable into a function, it becomes a local variable then within that function that takes on whatever value was assigned to it. So even if this side length fires somewhere else within our program and changes a value, it's going to retain the value in here that initially comes when it's passed in. Now let's just go over an example and show why this might be important. Let me come under my blocks here and under variables, and I'm actually going to use this set block, and within here I'm going to set the side length to something different, and I'm going to set it to something like let's make it really small so it's obvious, like 10. And out here I'm going to make this side length variable very something bigger, which is very obvious. Okay, so just taking this out of here for a second and running this, and I hit play. And so we're getting 125 passed in, right? Because here it is, it gets passed in. And so we get this square with 125. Now, if I were to not use this length that's getting passed into the function, I could again use this side length here, and I could use that and hit play, and we'd get the exact same result. So you might wonder, like, why are we even passing in a parameter? Why aren't we just setting the parameter before we call the function? Well, I think it's important because at some points in time in your code, you're going to have code that's branching and that's firing at different times. So it's possible to pass a value into that function, and then before this code actually runs down here, something might fire off somewhere else in your program and change the value of this side length variable. So by putting it within here in the block and passing it into the function, we know exactly what the value is going to be as we're passing it in, and we know it's going to retain that value. So just to show you this example here, what if we were to come up here and right at the top of this, we were to set side length, so this side length variable, and we're going to change it to something small within here, so something like 5. Okay, obviously then if we're using this move side length here, it's going to be reflective of this. And so when we hit play now, we'll see that now suddenly we're getting this super small square. I'll make it a little bit bigger just so we can see it is still drawing a square, but suddenly it's a lot smaller because the value here is being changed. So imagine this isn't happening here, but this may happen at this point in time somewhere else off in the program, when really we wanted to pass in and maintain this 125 value. That's why it's so important that we pass it in and then we grab this length variable here, because this length variable gets established at 125. That's what gets passed in. So even though side length changes here, the value is already passed in. So if we run this again, we'll see that it is maintaining that 125. So the takeaway here is just that as soon as you pass something in to the function right here in this declaration statement, it is initialized within that function and it becomes its own independent variable. And so even if that variable here that was getting passed in changes somewhere else, this is a new length variable now within this function, right? So a local variable within the function, even though this variable outside the function, which initially was used to define the value, that can change, and this length here is not going to change. So hopefully I didn't confuse you there. It's just an important distinction. It's important to remember because, again, we've talked about before, with control structures, you get into this branching code and these things that are firing off at the same time, and so it can be something that can become confusing if you're not using the local variable here that you pass in, and instead you're relying on a value outside the function not changing. It might work, but it also could be a case where suddenly you start to have problems. So when you pass it in here, you're taking total control, and you know that it's initializing with that value. You know it's keeping that value unless you change it here locally within the function, because this length variable here is not available anywhere outside of this function block here. Right? So it's not going to be changed anywhere else in the code. This is local to this function, to this custom block. Okay, so that was all about creating custom blocks or functions within MIT Scratch. I hope you learned something. If you did, don't forget to like and subscribe below so you can see more videos on this channel about programming. Thanks so much. Have a great day.